Alright, so this is day 12, radicals and fractional exponents. Last week we had that rotating day where we looked at and started to explore this on the board, on how this works. So radicals and fractional exponents are actually related, so your objective is on the board. Let's all read the objective out loud. Ready and begin. I will convert fractional exponents to radical expressions and vice versa. Okay, good. So that's what we're doing. Steps are on the board. If you're on the video, you should pause it. Otherwise, here we go. So numbers 1 and 2. So number 1. Okay. So on number 1. We've got k to the 3/4. I want to convert this to a radical expression, okay? It's starting with a fractional exponent, so that's okay. Not a big deal. K to the 3/4. Eyes up here right now. Eyes up here, pencils down. So in number 1, we have k to the 3/4. So another way to think of k to the 3/4, we have to divide, or we have to get the numerator and denominator to be a little bit separated. So I would rewrite k to the 3/4 like this right now. So let's make sure pencils are down one more time. Okay. So number 1, I'm going to write it with a basic k, but instead of 3/4, I'm going to say it's k to the 1/4, and all of it's being raised to 3. Right? Isn't that the same thing as 3/4? Right? When we have k to the 1/4 raised to 3, power raised to a power we multiply. Okay. The reason why I want to separate is because now that the denominator is by itself with a 1 on top, we're saying, what's the 4th root of k? So I can rewrite this easily saying, what's the 4th root of k? So I'm going to put, instead of 2 in my index, I'm putting 4. This is the same thing as this. Do y'all see that? Okay, this is the same thing, except that all of this is still to the 3rd power. So I'm still going to have to take my answer, put it in parentheses, and leave it at the 3rd power. And that's it. That's all we're doing today is converting it. Okay? So how did I convert it again? I want to take the fractional exponent and I want to convert it to a radical expression. So how do I do that? I want to think of this in terms of like anything to the 1 somethings. So in this case, the denominator is 4. So I want to think of it as k to the 1/4. So k to the 1/4. All of this raised to the 3rd power is the same thing as our original problem. Then I know this k to the 1/4 is the same thing as the square root of, or the 4th root of k. All of this raised to the 3rd power. Okay? Exactly. The numerator is the power, the denominator is the index. Okay? Showing this extra step so conceptually you see what's going on. Okay? Look at number 2. I'll do this one more time. We're going to go backwards. So we got the 3rd root of 6r, all raised to the 5th power. Okay? So I'm thinking backwards now. I want to make a fractional exponent. So I'm going to take 6r as my base. I'm going to start with that. And since my base 6r is inside the radical sign, I'm going to put that in its own parentheses. And I said it was the 3rd root of it. So instead of being leaving it as a radical, I'm going to say it's 6r to the 1/3. And all of that still was raised to the 5th power. So that 5 stays outside. Okay, so I just brought that down here. Okay? Then I want to multiply 1/3 times 5 because we have a power raised by a power. It's going to be 6r to the 5/3, and then we're done. That's all we're doing. Okay, so today your goal is to take the original fractional exponent, change it to a radical expression, or you're going to take the radical expression and change it to a fractional exponent expression. Does it make sense? Okay, basic skill. It is a bit confusing, but as long as you learn the basic skill, you should be okay when we do the harder problems. Okay, any questions on numbers 1 or 2? Yes.
So does that say 6R?
This is 6r. 6r.
Why wouldn't you multiply it 5 times? Is the exponent, why would you do that?
Because this is a simplified version. Is there a 3rd root of 6r? So you can't multiply it 5 times if there is no 3rd root. That's why we have a fractional exponent, because we can't simplify it anymore. So let me help you out a little bit to help you understand this. What if it was 27 to the 4/3, okay? Can I simplify that at all? Well, let's talk about that. Isn't this the same thing as 27 to the 1/3 raised to the 4th power? Would you agree with that? Okay. And wouldn't you agree that 27 to the 1/3 is like saying the cube root of 27, all raised to the 4th power? What's the cube root of 27? 3, right? 3 times 3 times 3 is 27, right? So then we would say this is the same thing as 3 to the 4th. What's 3 to the 4th? What's 3 times 3 times 3 times 3? No. 81. So I could look at this whole original problem and jump down to 81. Does that make sense? But can I do that with this problem here? No, we can't break down 6 anymore. We don't have a third root of 6 or a third root of r. So your question's good. I like the way you're thinking. It just doesn't work here. That's why we're stuck with this fractional exponent, because we can't simplify it anymore.
Will we have to do anything about that?
What?
What you just did. Will that show up at all?
Yes, it will. Yep, it will show up. So you could write all 3 of these now, okay? Number 3. Okay? So, we got a to the 1/2. What does that equal to when we rewrite it as a radical? Okay, this is a trick question. Don't overthink it. You just write it down. You write it down. This is by yourself right now. So that's number 3. That's the answer. Number 4. So in number 4, right, this is the same thing as saying conceptually 6n. What's the third, or 6n to the 1/3 power raised to the 5th? And then anything to the 1/3 is like saying the cube root of it. And then all this, so here's your final answer. If you got it right, show your neighbors. If you got it wrong, figure out where you got it wrong. Talk to each other. Okay, continuing on, number 5. Number 5. Let's have you pause and do number 5 here. So this is the same thing as saying x to the 1/5 raised to the 7th, right? Which is x to the 7/5. Now, some people are like, do you need a parenthesis here? No, you don't necessarily need one because it's redundant. Now look up here. What if the answer was this? What if you had like a, let's say the original problem had a 7, and then you had a 7x. Let's say the original problem had 7 all the way up in the original problem. You see? Do you need a parenthesis? Yeah, you know why? Because what is the current, what if this 7 doesn't have a parenthesis, what is the exponent we assume is above the 7?
1.
A 1. So if you don't have a parenthesis, you're saying it's 7 to the 1st times x to the 7/5, which is incorrect. You would want to have a parenthesis around it. But that's not the case. So because it's by itself, we're just going to leave it alone, x to the 7/5. Okay? If you have a parenthesis, that's okay. Talk to your neighbors about where you may have made a mistake, or if you did it right, that's good. You don't ever want to add stuff while I'm writing, because then you might get confused. Nothing. Okay. Last one, number. Here we go. Number 6. Oops. Number 6 here. Last one. Please write this as a fractional exponent. Number 6, don't erase your board. You're checking your work because some people forgot certain things like... Hope it's still working here. Okay, so number 6, here's your answer. Number 6. We have 3m, parentheses on each side, right, to the 1/3 to the 5th, and then your final answers need to have the parentheses. Do not erase your boards. Okay, talk about it if you got it right. If you got it wrong, please also talk about it, okay? Some people didn't do it right. They forgot the parentheses. Okay, ready, set, go. Okay, is it important that we have the parentheses here, yes or no? Yes, absolutely. So, that's it. That concludes our lesson. Please